Way out in the cold, dark reaches of the solar system, orbiting the giant planet Jupiter, there's a world that just shouldn't exist. A world not of quiet ice, but of nonstop fire. Today, we're going to dive into the incredible story of Io, the most volcanically active place we've ever found. Everything we knew about planetary science suggested that a moon this small and this far from the sun should be a frozen, dead rock, kind of like our own moon, covered in craters. But what we actually found? Well, it was a wild, colorful canvas of yellows and reds and blacks, a landscape being constantly repainted by lava. I mean, the contrast is just mind-blowing. So that leads us to the big question, right? The cosmic mystery we're going to unravel. How does a moon that's supposed to be frozen solid have enough heat to become a world of constant, furious eruptions? What is going on here? Okay, so here's the heart of the paradox. A world Io's size is just too small to have held onto the heat from its formation all those billions of years ago. It should have cooled off and gone geologically dead eons ago. And we're not talking a little bit active here. It is the most geologically active body in the whole solar system. Its surface is constantly being paved over by fresh lava, which completely erases any impact craters. It's a true freak of the cosmos. And figuring this all out was a journey. For hundreds of years, Io was just a tiny dot of light in a telescope. Then, boom, 1979, NASA's Voyager 1 flew by and just blew the doors off planetary science when it saw giant volcanic plumes erupting from the surface. And every mission since, like Galileo and Juno, has just shown us how much more powerful this little world really is. Okay, so if it's not old heat from when it was born, where is all this energy coming from? Well, the answer is an absolutely relentless gravitational battle. A cosmic tug-of-war. The engine powering this whole inferno is a process called tidal heating. And no, we're not talking about ocean tides. We're talking about the actual rock and mantle of the moon being physically stretched and squeezed by gravity. This constant flexing generates an unbelievable amount of heat from sheer friction. So here's how it works. Io is locked in this very special orbital dance with its neighbors, Europa and Ganymede. They keep tugging on it in a way that forces its orbit into a slight oval, not a perfect circle. So as it swings in closer to Jupiter, the planet's massive gravity stretches it out. Then, as it moves away, it relaxes back into shape. This constant squeezing and relaxing happens every day and a half, and all that friction builds up in insane amounts of heat. Enough to melt rock. The best way to think about it is like bending a paperclip back and forth really fast. It gets hot, right? That's friction. Now just imagine that on the scale of a moon being yanked around by the biggest planet in our solar system. The heat it generates is just colossal. All right, so we've figured out the engine. We know the why. Now let's look at the spectacular world-shattering results of all that internal heat. This is where the story gets really wild. First up, the volcanoes. We're not talking about a handful. We've identified over 400 active volcanoes dotting Io's surface. And those are just the ones we've found so far. The whole moon is basically a volcanic minefield. And the lava they spew is just ridiculously hot. We're talking over 1,600 degrees Celsius. That's hotter than any lava you'll find on Earth today. It's probably a lot like the kind of lava that flowed back when our own planet was young and fiery. And the eruptions, they are absolutely monstrous. The plumes of sulfur and ash can blast upwards of 500 kilometers high. That's so high that the material actually escapes Io's weak gravity and shoots directly into space. And this isn't some ancient history. This is happening right now. Just recently, the Juno spacecraft spotted a single volcanic hotspot, just one feature, unleashing 6 times more energy than all of Earth's power plants combined. The scale is almost impossible to wrap your head around. So, here's a crucial point. Io isn't just some isolated freak show. This tiny, violent moon actually has a huge effect on its giant neighbor, Jupiter, and the entire system around it. All that material getting blasted into space doesn't just disappear. It forms this giant, invisible donut of charged particles around Jupiter called the Io plasma torus. It loads up Jupiter's powerful magnetic field, which in turn helps create those spectacular auroras at the planet's poles. And it also creates intense radiation belts that are a huge hazard for any spacecraft we try to send there. So this all builds to something bigger. Why should we care so much about this distant, volcanic world?
What does the celestial hellscape actually teach us?
Well, Io is incredibly important. For starters, it's like a window into the past, showing us what fiery young planets like the early Earth might have looked like. Even more amazing, the same physics that melts rock on Io is probably what keeps a liquid water ocean sloshing beneath the icy shell of its neighbor, Europa, a top spot in our search for life. So Io is a natural laboratory for extreme geology, and it helps us understand how even distant exoplanets orbiting other stars could be kept active and warm by their own gravitational dances. In the end, the story of Io forces us to completely rethink what can make a world geologically alive. It's not always about a star's warmth. Sometimes, as this incredible violent moon shows us, it's about the dance of giants, a gravitational waltz so powerful it can flex an entire moon right down to its molten core.